Billion shows that with higher temperatures, Switzerland won't have any glaciers by the end of the 21st century. Ladies and gentlemen, unfortunately, I have a busy schedule, so I will have to leave you very soon. I will listen to your interventions because I appreciate your scientific commitment. It is crucial. I would like to thank you for listening and wish you all the best for the rest of this COP26.
Merci, Monsieur le Président.
Thank you very much, Mr. President, for your words for the people in charge of research, taking into account the impact of climate change on cryosphere in Switzerland and elsewhere. And thank you for reminding us about the target of 1.5 degrees.
And indeed, there is another link between Glasgow. You might have heard that all of the cities who've had a COP now have a glacier named after them in West Antarctica. And back in 1979, Geneva was also host of the climate COP. So I would like to encourage everybody to ask questions, and for our virtual audience who are joining us, please do put questions in the Q&A. You can ask the questions in French or English. Please also do tweet using @GE_CryoHub or the hashtag GECryoHub, and of course there's the hashtag COP26. But with no further ado, I'd like to ask our host, the Vice Rector of the University of Geneva, Jean-Marc Triscone, to say a few words.
Thank you very much. Monsieur le Président de la Confédération.
Mr. President, Ambassador, the Director of IC, guests, dear colleagues, students, ladies and gentlemen.
Very pleased to open its walls, and it's to promote, once again, the dialogue, the debate, and especially the dissemination of science knowledge on the subject of climate change. The remarkable work Professor Geraldine Flieger will come back to in a minute, carried out on a daily basis by our researchers, allows us to have a detailed, reliable, and unfortunately today, particularly alarming knowledge of the evolution of the terrestrial ecosystems, and in particular the cryosphere. The specific field demonstrates, if it were necessary, that in this area, as probably in others, Switzerland will not remain a protected island, but will suffer the full consequences of this disruption with the rapid and massive melting of our alpine glaciers, causing changes in the availability of water resources. At the same time, this also demonstrates the need to act everywhere and at all levels to decarbonize our societies and preserve the capacity of our planet to host life. Our institution, the University of Geneva, is committed to reducing its emissions rapidly and massively in order to act in coherence with the conclusions drawn by our researchers. The University of Geneva SDG strategy places our actions within the framework of the 17 SDGs and in respect to the planetary limits. Our environmental ambitions, air travel policy, SDG in the lab, cafeterias, buildings, energies demonstrate our will to act on all fronts, but we cannot succeed alone. For this reason, we encourage our community, students, our administrative staff, and all the researchers to act with us to support our commitments and to spread the knowledge that we transmit daily through our teaching. We also collaborate with Swiss universities, the RERU, and international networks to define methodologies, objectives, and best practices so that the higher education sector can be an example for a low-carbon society. The pandemic that continues to affect our society has demonstrated that even when borders a physically close, connected scientific community has continued to play its role in analysis, knowledge creation, and solution coming in an incredibly short time with vaccines. The fruit of international efforts, exchanges of researchers and data, and intense, amazing collaborative work. Faced with the major challenges that await us, climate change, biodiversity, it is essential that Swiss research can continue to play its role, not alone, but strongly connected to European and international networks. The situation today is a nonsense, and everything must be done to allow us to reconnect to the European programs, to all contribute to the incredible challenges our societies today face. Coming back to our tonight, we are once more very pleased to host it at the University of Geneva, an hybrid event that gives us an example of maybe the way to go, taking less airplanes, favoring when possible the transfer to video conferencing, placing ourselves on a zero emission trajectory. I wish you a good evening here at the University of Geneva or online. Thank you very much.
Thank you very much indeed for your words about the importance of scientific research and education. It's now my pleasure to ask Ambassador Stefan Estermann, who's head of the Prosperity and Sustainability Division at the Federal Department of Foreign Affairs, to say a few words. The floor is yours.
Monsieur le Président de la
Mr. President of the Confederation, Vice Rector of the University, Associate Secretary General, ladies and gentlemen, professors, students, dear colleagues, here in Geneva and in Glasgow. First of all, I would like to address a warm welcome to the whole team of the University of Geneva for having organized in such a limited time the Geneva Cryosphere Hub. I am delighted to be able to be with you today. The idea behind the hub is to create a bridge between the epicenter of diplomacy in Glasgow, the COP26, organizations are both concerned by climate change with long-term for ecosystem, but also for men and for the economy. On behalf of the Federal Department of Foreign Affairs, I would like to welcome you to this event. It's really to create bridges between Glasgow and Geneva, between high altitude zones and the poles, but also, and more importantly, between scientists and diplomats. Thank you very much and have a nice event, everybody.
Indeed, the role of diplomacy, after all, is to build bridges. Do come and join us. And Geraldine, back to you in Glasgow.
Thank you, Claire, and thank you to the ambassador and to our vice-rector for this very important work, both for science and the environment and curiosity. Brilliant scientists that would give us a talk from the youngest generation of science and research on glaciers. And we will begin with the Professor Sonia Seneviratne from the on climate extremes in the climate change from the conclusion of the first group, working group of the IPCC Assessment Report 6. So now I give the floor to Sonia in Glasgow and to Geneva.
Thank you very much, Geraldine. It's a presentation. Thanks to other organizers. So I will be presenting slides on the latest report from IPCC. It should be shown on the screen, I assume, because it's shown in Geneva. We are not seeing the slides here.
They are with us now. Thank you. We can see them.
Thank you very much. So actually, I'm not a specialist on cryosphere. I'm a climate scientist, but what I will present is a more general picture on change in global climate. So I wanted to start with the evidence that we have so far on changes in global temperature. And what you see is that we have had a major increase in temperature since the mid of the 19th century. So we already had 1.1 degree of global warming in the last decade. And this warming is unprecedented in more than, the warming rate is unprecedented in more than 2,000 years. The warming level itself is unprecedented in more than 100,000 years. Now, what I will always say is, this means that this warming level we are living with at the moment, it's actually a warming level that human civilization was never basically facing in all of its history. So we have to realize this is truly outstanding. The largest part of this warming is irreversible for next generations because CO2 stays very long in the atmosphere. Now, in terms of the cause for the warming, we can say it's us. So it's unequivocal, that's the conclusion of the IR6 report, that human influence has warmed the atmosphere, ocean, and land. And almost all of the global warming is due to human-induced emissions, as you can see in this figure. Next slide, please. Now, the changes in climate extremes, focusing on Switzerland, since much of our audience is from Switzerland. Climate change is already affecting every inhabited region across the globe, with human influence contributing to many observed changes in weather and climate extremes. So you see on the right, I realize now I should be turning the other side maybe. Yeah, you see on the right the maps of the changes in extremes, and you see that most regions are at least affected by one type of change in extreme. For instance, in the case of temperature extremes, almost all regions are affected. But you also have major changes in heavy precipitation and in droughts in several regions. Next slide, please. Just to provide some example of recent events that have occurred, we know several of those events were made more probable due to human-induced climate change. An example is, for instance, recently in France, for the first time, 46 degrees was reached. And in Australia in 2019 to 2020, there was major heat wave and drought, also leading to fires. In Siberia, and that's also related to the cryosphere regions, for the first time within the Arctic Circle, a temperature of more than 18 degrees was reached. And of course, this year we had a major number of extreme events. Just to provide a few examples, we had in Canada, temperatures of 49.5 degrees. Then in Western Europe, particularly in Germany, there were very heavy precipitation, which led to floods, and many people died of this event. And then in Mediterranean, there were major fires that happened. So we are seeing that climate change is already leading to deaths, human people dying in several regions, even in developed countries. Next slide. So what will happen after 2030, that's basically sure. And that very much depends on what we are doing now and what we decide now. So projected changes in extremes depend very much on the level of global warming. The higher are the change in intensity and frequency of climate extremes. This is the case in particular for hot extremes, marine heat waves, heavy precipitation, droughts of several types, including agricultural droughts, and also the proportion of intense tropical cyclones. We have already much higher risk at 1.5 degree compared to 1 degree. And at 2 degree, obviously, we would have even much larger changes compared to 1.5. So I want to say a few words about compound events. What we mean by compound events are events that basically happen at the same time in the same location. They can be of different type. One example is drought and heat waves happening in the same location. We can lead to fire, or you can also have a different event happening in different locations, such as affecting the different breadbasket regions of the world. And we see that with global warming, every region is projected to increasingly be experiencing multiple changes in climate impact drivers, including extremes and also including those compound events. Just some examples of these compound events which are increasing. We have the concurrent occurrence of heat waves and droughts, also more frequent fire risk, and also compound flooding. So for instance, when you have tropical cyclones happening at the same time with sea level rise, this leads to more flooding. And the third point, what I mentioned, was this change in extremes in different crop producing regions. This would be much more risky at 2 degree compared to 1.5 degree and could lead to a problem in terms of food security. Next slide, please. So I come to the conclusions of this short presentation of changes in climate extremes, which has been much strengthened compared to the last report. And we see that no region is spared from change in extremes. We see also that unprecedented events becomes more likely with increasing global warming, and that threats from extremes are multiplying with increasing global warming. Which we will be facing beyond 2030 depend on what we decide now, how much emissions we have. If we want to limit global warming to 1.5 degrees, we need to reduce emissions by 50% until 2030. So we need to reduce immediately the emissions every year. I come to the last point, which is we should do all we can to limit global warming to 1.5 degrees. 1.5 degrees is not safe, but it's the best that we can do. Thank you very much.
Thank you. Thank you, Sonia, for this very complete overview on the impacts and the pace of climate change. And now I'm giving the floor to the Professor Samuel Jacquat, who is going to talk to us about high latitudes and with a talk on the status of and future of polar regions. Thank you, Samuel.
Bonjour à tous. So thank you very much for the invitation
Hi to everybody.
to be here and have this opportunity to present some of the latest results also from the assessment report 6 of the IPCC, and I'll be focusing on the polar regions. Next slide, please. As was just mentioned, and as we all know, the globe has warmed by 1.1 degree on average, as you can see on that map. But you can also see that the polar region, and in particular the Arctic, has warmed much more by a factor of 2 or 3 in a process or mechanism we refer to as polar amplification. Next slide, please. Next slide, thank you. So as such, the polar regions represent the sentinels of the climate system, in which we can already observe and measure the impacts of a 2 to 3 degree warming. And this 2 to 3 degree warming will have a particular impact on the cryosphere, that is the glaciers, as we heard, permafrost or the bare ground, as well as please. So for the longest time, now talking about the Antarctic ice sheet, so this figure shows you the mass bilan with mass loss in gray and mass gain in blue. And so you can see that for the longest time, the scientists were thinking that the Antarctic ice sheet was relatively immune to climate change because 1 to 2 degree warming wouldn't affect the melt rate of the ice too much, since the continent is very cold. But as you can see, Antarctica is losing mass in its coastal regions, in particular where ice sheets interact with the oceans. The oceans are warming, and the arms of the ocean is starting to erode glaciers or the ice sheets from below. And so we have a loss of mass in coastal regions, particularly in East Antarctica. And the situation in, say, a bottle of champagne, one cork or the ice that is holding the ice sheets behind, then you can lead it can lead to a catastrophic discharge of the ice. The projection based on climate models that you can see on the right show that the coastal region, and particularly the East Antarctic ice sheet, will lose mass in the coming decades. Next slide, please. The situation is much more different in Greenland and in the Arctic in general. You can see again that most of Greenland is losing ice as a result of warming, especially on the western coast, where both temperature and increased precipitation in the form of water contribute to melt the ice sheet. Now, if we look on the right-hand side, the projection for the end of the century suggests that the Greenland ice sheet will lose a significant amount of ice, with dire consequences for ocean circulation, for example, and local ecosystems. Next slide, please. Obviously, the loss of ice and continental ice on both Greenland and Antarctica will contribute to rise sea level. Sea level has risen already by about 10 centimeters globally. And if nothing is done to decrease or halt global warming, then sea level will increase much more dramatically by up to 30 to 40 centimeters by the end of the century, with dramatic consequences for coastal habitat as well as resources. Next slide, please. So global warming is not only affecting Greenland ice, but also sea ice. So as you can see on the right, there are satellite images of the coverage of sea ice and the decrease in sea ice coverage from the end of the 80s to today. And you can see the dramatic decrease, especially in the summer extent of sea ice. This is on the left-hand side, where you can see a reduction by several million square kilometers in the coverage of sea ice, which is relatively straightforward to measure by satellite, but also what is much more difficult to measure, but we also realize now that sea ice, so the thickness of sea ice has been decreasing quite dramatically, and most of the sea ice that we observe now in the Arctic is only 1 or 2 years old, okay? And the decrease of sea ice has dramatic consequences on the heating of the ocean, because the sea ice is reflecting most of the incoming solar radiation back to space. So when sea ice has completely disappeared, then most of the incoming heat is actually absorbed by the ocean, which will accelerate the heating of the ocean as well as further melting the sea ice. Next slide, please. And to resonate a bit with the thematics of that conference, model predict that sea ice will completely disappear by 2050 if nothing is done to prevent sea ice, with obviously dramatic consequences on ecosystems in high latitudes. Next slide, please. Right, so I'm just going to reiterate the conclusions that Sonia made before. It's absolutely imperative to reduce greenhouse gas emissions to limit global warming to less or 1.5 degree. And as Sonia mentioned, maintaining global warming as reduced as possible will hopefully avoid crossing irreversible tipping points, such as the total disappearance of sea ice, which, if it disappears, then it will probably never appear again. Thank you very much for your attention.
Thank you, Samuel. And I forgot to present you, just to say that you are professor at the University of Lausanne in the Institute for Geological Science. And now I will give the floor to Dr. Matthias Huss from the ETH, Zurich, and who is going to address now high altitudes.
Thank you, Geraldine, and thanks for the invitation. So I'm going to the topic of this mountains without ice. I'm trying to give you a little insight in how glaciers are responding to climate change in Switzerland, but also at the global scale. Next slide, please. Glaciers are the ambassadors of climate change. They have a very clear message. They show to everybody, not only to scientists, that climate is changing and that the changes are fast and big. This is why glaciers are so important, because they visualize the changes. Next slide, please. These changes are so fast. Here we have a time lapse of a retreating glacier over only 10 years. And you can see the ice disappearing within a glimpse. So it's not generations that it takes to melt away glaciers. It's a decade that is enough. Next slide, please. These changes are dramatic, and they're not only dramatic in Switzerland, they're also dramatic in other parts of the world, like in Alaska. We see a huge glacier disappearing within 60 years. And the question is really, are we going towards a world? Next slide, please. Next slide. Yeah, so we're looking at the Great Alleged Glacier, the biggest glacier in the Alps. And on the left, we have the model change until 2100 if there is no climate change mitigation. On the right, we have the change with reduced CO2 emissions. This is what we're aiming at. So we see the glacier is going to retreat dramatically in all cases, but still the difference by 2100 are big. It means we still have the power to limit some of the consequences, although much of the ice is already committed to disappear because the climate has already warmed too much. Next slide, please. We're going to look at the global scale, at the global glaciers that occupy all the mountain ranges around the globe. And I'm talking about these blue dots, except the two ice sheets that we have just heard about. Next slide, please. So what is the change in this glacial volume that we have on Earth if the climate is warming by 5 degrees at a global scale or by 1 degree at a global scale? By 5, lose about 2/3 of all glaciers. This is a lot, and it will continue beyond 2100. If we manage to limit climate warming to 1 or 2 degrees, there is still a big difference. We only lose about 1/3. So there is still a big range of action that is still left, although we are losing many glaciers, especially in those regions that have small glaciers. Next slide, please. What about the impacts? We're speaking about permafrost that is thawing, this ice holding together the ground. Everywhere on Earth, it is observed that permafrost is warming, that this warming is causing, that this warming is causing massive slope instabilities, like the big rockfall event on Pico Cengalo, that are dangerous to downstream communities. Next slide, please. What about sea level rise? This is obviously the most important of changing glaciers, but combined with the melting of ice sheets and combined with other components. By 2100, the world is going to face sea level rise in the order of plus 40 centimeters to plus 80 centimeters. This is still manageable. It's not that bad, but next slide. At the very long time scale, we see it in the no mitigation scenario, where no climate change measures are adopted. We might go into a world with sea levels being up to 4 meters higher than today. And this is catastrophic for many coastal communities. Next slide, please. Finally, the mountains as water towers. So mountains are a vital water resource for many communities. And if glaciers decline, if snow disappears, This has an influence on runoff, on the water availability in many regions. So first, we'll have more water because the ice is melting up to a certain point. Next slide. But the water is going to decline strongly, especially in the summer months when we have most need for the water. And so this decline in the summer months in the mountains, this will pose massive challenges for communities living in the mountains. So at a global scale, we see some hotspot regions for the impacts of climate change, glacier decline on water resources. These lie in Central Asia and in the Andes, and at a bit smaller scale, also in Europe and Western Canada. Next slide, please. So to sum up and put some key messages here, glaciers are a visual manifestation of climate change and therefore very important to convey a message. There is a rapid and accelerating trend in glacier decline and permafrost thaw in the Alps, Switzerland, and worldwide. And then finally, there are many, many impacts that are severe. But the good message is there is still a range of action where we can limit these impacts. Thanks for your attention.
Thank you, Matthias. And we will take the word that you just said, a range of the round table that is going to be open soon in 2 minutes, is dealing with science to ambition. And I would like to say, just to put it in the context of what happened here in Glasgow right now, Claire, that, for example, while we are talking, there is next to us several pavilions on the impacts of climate change on water. On the role of science, we are close to the IPCC and science pavilion, and we can see how cryosphere, water, and science, all of this is connected. The structured expert dialogue of the convention is also running these minutes, and the IPCC researchers are now delivering the latest. They published in August 2 parties, and it's very important to make this link between science and action and ambition. So I will back to you now, Claire, just to open this roundtable in Geneva on science to ambition.
Thank you very, very much, Geraldine. And I'm delighted to be joined here by the Deputy Director General of the World Meteorological Office, Dr. Elena Manenkova, another climate scientist, Markus Stoffel, who will be known to many of the students, I think, here at the University of Geneva, and Ambassador Stefan Estermann. You heard that he was the head of Prosperity and Sustainability Division of the Federal Department of Foreign Affairs, but is also Switzerland's representative on the Arctic Council. So let's start with the science before we go to the ambition. Markus, we heard some of the impacts there from Matthias about what can happen in Switzerland if we don't keep temperatures below to 1.5 degrees. Can you elaborate on some of the risks that we're going to face here if the ice, the snow, the permafrost, the glaciers all start to melt at great rates?
With pleasure. I don't know if you can hear me. Is the mic working? Now it's working, yeah. So what we've just seen in the presentation that was given by Matthias Huss, so if we lose most of the glaciers and if we have warmer temperatures, we will have less water availability in summer. So we will not have the water from the glaciers anymore. We will have the snow, if it is still falling in the form of snow and not in the form of rain during winter, melting much earlier. And the summers in Switzerland are typically drier than the winters are. So what we will have in small mountain streams is a lack of water. So we will have drought situations. If you take the example of Valais, where we have these irrigation channels, these bis, these will probably fall dry, and they have been used over centuries to irrigate meadows, to irrigate fields. That's one issue. Also in winter, for winter tourism, we will not necessarily have cold enough temperatures to have elevations. So the tourist resorts located at lower elevations, I think here of the Swiss plateau, of the Vaud mountains, for instance, the Bernese Alps, the stations are pretty low. And even if you would potentially have the equipment to produce artificial snow, you may not have the temperature to produce that snow. So it will also be a challenge for winter tourism. But even more so, in a future climate with limited water resources, where would you allocate the priorities? Is the priority for snowmaking production and hydropower? Do you give the priority to agriculture, or is it the domestic use that is going to be prioritized? So there are lots of questions that are not solved. And Switzerland, it may sound contradictory because we are one of the water towers in the world, but we might, in the long run, be short of water. Speaking of risks, maybe of the risks in the mountains, Matthias was making reference to the melting of permafrost. He was showing one very drastic example that occurred a couple of years ago in the canton of Grisons. We also have smaller events, landslides, debris flows, rock falls occurring more and more frequently. Some hiking trails had to be closed in recent years. And these events where the permafrost is no longer in the debris or in the bedrock, so when this conch is appearing, many mountain slopes will become unstable.
And the news is not good beyond Switzerland either in these high altitudes.
I mean, there are problems all over the globe. Switzerland is not alone. There are other regions like the Himalayas, with Ladakh, just as an example, a place that is typically very dry. The capital of Ladakh, Leh, depends on one small glacier that's a square kilometer in surface. And if that glacier is disappearing, then basically the whole water supply is disappearing in this region, which does not receive much rain. Problems also exist in Chile, for instance, which is typically dry, and where also lowland communities depend critically on the water from melting glaciers and from melting snow.
Stefan, the Arctic Council, what is that doing? It often comes under sort of criticism, perhaps, for not doing very much on the environmental side of stability up in the Arctic. But what is it trying to do to try and preserve the Arctic regions?
Well, the Arctic Council is quite a unique international organization, bringing together the 8 riparian states of the Arctic, including an official representation of the autochthonous people actually living in this region. And these people are the witnesses of climate change. They have been living for generations, and in their everyday life, they see actually what is happening, and they are living the impact of climate change on their livelihood. The Arctic Council is an organization based on consensus. There is a real dialogue taking place between big players, like, for example, Russia, the United States, Canada. I would, as far as I can judge from an observer, is one that is really respectful. I feel this kind of atmosphere of being an Arctic family. And I think this is a very good basis to cooperate, especially in the research area. I think the Arctic Council is a great organization with its different scientific working groups to advance Arctic research. And that is perhaps the main reason why we, Switzerland, applied for being an observer in this Arctic Council. It's interesting for us from a political perspective, but it also opens the doors for our research community.
We've seen, obviously, the high altitudes, the high latitudes, but Eleanor, it's really the whole of humanity that's going to be impacted if the cryosphere disappears. That must be obviously a concern to the WMO.
Thank you, Claire, and I'm very glad to be in the company of scientists, because WMO is technical and scientific specialized agency of United Nations, and its authoritative voice of science to the policy. So, and I'm very proud to say that because it was not obvious or apparent 60 years ago when WMO issued the first statement on the climate change. WMO is issuing annual reports of what happens in the world. And most recently, last decade, we started also looking at what it means for the people. What are the impacts? Because this speaks most loud to the policymakers. The most recent report, which was just announced yesterday in Glasgow by my Secretary General, Peter Tallis, doesn't show any surprise. It actually confirms what we have seen on the last year through our observing networks and monitoring, what IPCC already said. So let's go to the mountains. So the mountains, as well as high altitude areas, Arctic in particular, are probably hot spots on the planet right now. We said that we have now an average 1.1, approximately 1.1 degrees above pre-industrial. However, this 1.1 is mean average on the planet. This is much hotter in the Arctic, and it is much hotter in the mountains. This year, my colleagues in Glasgow depicted some record heat temperatures, and I can tell you dozens of records which we see every year, records in floods, records in temperatures, records in ice loss, records. But just think of it for the second. Last year, the heatest point on the Earth was Verkhoyansk, which is Arctic Siberia. That is cold pole. Mm-hmm. This area is already 5 hotter than pre-industrial. So we have significantly disturbed water cycle. What happens in the mountains? The warmth is going in the higher and higher altitudes. So the ice is melting with the increased speed. So we just said in our report that from 2015 up to now, we have lost in our reference stations 1,000 kilograms of ice, which is equivalent of 1 meter. So this is a huge amount. What happens? So ice is lost. The income of snow doesn't compensate anymore the ice to form the new ice, to make a new ice. But in the same time, these areas are more affected to precipitation, to liquid rain, which means that for communities living there, the impacts are becoming extremely challenging. So I can also give you another shocking example. We just recorded in August 14, rain in Greenland, just first time forever. And this trend will continue. So just to summarize quickly, I have thousands of things to say, but to summarize quickly, why it matters for us. Everything is connected and everyone is interconnected. Losing water, sea level rise. Sea level rise, 4.4 millimeters per year. Its accelerated speed affects all coastal communities. Risks are higher, and risks are also higher for mountain areas because of the rain and there is no snow. There is lack of water, means water stress, and we have water stress points all over the world. So for us in WMO, it matters that we need to save lives. For us, every bit of warming matters because every bit of warming increases risks, increases vulnerability of people, and we need to do lots of work to have proper forecasting, proper warnings, and to get them to the people. Just to conclude with this, my first intervention. Thank you.
Yes, absolutely. And I do really recommend people have a look at that latest report, the Global Climate report that came out yesterday from the WMO with some very shocking statistics, as Elena was saying. Marcus, so we know what we know, and it's pretty depressing listening to everybody here, but what don't we know? Where, as scientists, are the data gaps that need to be filled?
I mean, there are several gaps, and as surprising as it may sound, we still do not necessarily have enough meteorological stations. We still have blind spots on the planet. We still have regions for which we do not have long enough or good enough data. And even in times when we know that measurement and monitoring is crucial, we have situations where some stations are given up, where some stations are discontinued. And for us, that's a major problem, because if we do not have measurements over sufficiently long timescales, it is difficult to really quantify the changes, to understand the dynamics and the processes then what we also have in a world where we reach temperatures that have not been recorded for millennia, it's then also sometimes difficult to know how important or how severe or how rare certain impacts are. So we often refer then to events without historical precedents or parallels, because human memory on the one hand is short, and if some events may have happened 1,000 or several thousand years ago, we do not necessarily remember them. So it's also difficult for us scientists to say, okay, the heat wave that we had, the temperature increase in a given location, how extreme was that? How rare is that? For us, it's difficult to quantify, and sometimes we need to correct these assessments. And this can then also be criticized by non-scientists, telling us that we're not knowing what we're speaking about. So we need more data, more measurements. Monitoring is crucial, and we need to still better understand the impacts of the warming that we're having.
Elena, is this also an issue for you, a lack of data in that, the baselines that are needed, for example, to show that an extreme event is really extreme because you've got the historical data?
Right, Claire, but let me, WMO is always talking about the lack of data and the need to have a proper data exchange, but let me tell you why it matters. Not only what my colleague said, to properly monitor and detect the long-term change, long-term trend, but most urgently, we need a proper amount of observations to do the high-resolution modeling. The WMO Global State of Climate is already a known product, but from this year, WMO started releasing regional climate products, significantly regionalized their assessment. So however, IPCC does it every 5 to 7 years, and WMO does it actually every day. We do need to have very detailed scenarios for the places, let us not even call it countries, for the places, like Switzerland has CH 2018, still very relevant climate scenario. They should be of high resolution and there should be high accuracy. But also we need those data to simulate what the weather is going to be like, because with the changing climate, the extremes are coming to the places people are not used to and ecosystems are not used to. So we need to have it as in advance as possible. Regarding the data per se, WMO has just concluded an extraordinary session of the Congress, and it was truly extraordinary because it adopted a unified data policy, which requires every single country in the world to exchange information freely and openly at the required resolution required. So this is
that's quite exceptional, because data is power, and it must be difficult sometimes to get people to share data.
And in the cryosphere, it's even more challenging because the locations are hard to reach, they're expensive to maintain, and they are implicated by national security or strategic considerations. So for us to really get to the free and unrestricted for hydrology data, for cryospheric data, this is a must. So we have a global cryosphere watch system, which is not yet operational. So we will be urging governments to exchange this information of all, because the data big sense if it's sitting within one hands. It only makes sense if it contributes to the global original simulations.
Stefan, you're an observer status on the Arctic Council, but what have you observed about the exchange of data between Russia, Canada, US, all of the members of that council?
Data are key, and data become more and more important for our diplomatic activity. This is very evident, of course, in the area of climate diplomacy. It is very evident, for example, what we see now in all the efforts to combat the pandemics. It is also very evident when we are trying to achieve the Sustainable Development Goals, the Agenda 2030 of the United Nations. We cannot achieve these goals without having solid data at our disposal. So one area where diplomacy and science has become much closer is in this area of having the right data to underpin our policies and our foreign policy. Yes, in the Arctic Council, there's a lot of effort going on to collect data, including there are some Swiss pioneers like Konrad Steffen, who installed a sensational network of measuring points across Greenland, for example. that dates back 20 years. So we have a lot of data. We have data collected by the University of Bern, where they managed to measure the CO2 content in ice cones for the past 800,000 years, which is a world record. And imagine these ice cones are being analyzed somewhere in Bern behind the railway station. It's absolutely unbelievable. So data are important. And I can also, confirm what you have been alluding at. Yes, sometimes geopolitics is, of course, the backdrop activities. We have to be aware of this. Sometimes it is an issue in scientific collaboration, and that is where, diplomacy sometimes can help. That's where we diplomats are to overcome such barriers to science and the gathering of data.
So we've heard what the scientists are doing. We've heard where the science gaps are. We've heard the diplomats who are trying to bridge the geopolitical differences. I am going to now introduce you to somebody who's joining us virtually, Dr. Sebastian Koenig, who's a senior advisor on international environment and sustainability policy at the Swiss Federal Ministry of the Environment. Welcome, Sebastian, because I think we've all heard, haven't we, politicians during the pandemic saying we're following the science, but are they following the science? Policymakers obviously need data to base their decisions on, but Sebastian is in a very interesting position because your background is as a scientist, but you're also now sitting there as a national civil servant making policy. So Sebastian, what do you need from the scientists so that the Swiss can make evidence-based decisions?
Thank you very much. Thank you, Claire. This is a perfect example. The three excellent presenters that we had earlier here on this event showed exactly what we need from science. We need evidence that is rigorous, credible data, as you said, that is peer-reviewed, and it also has to be independent. I think that's the first step that we need to have, because it's some credibility associated with science and scientific information, and what we can take then into our decision making in that sense. And what we saw earlier is that we need also good communication to policymakers. And I think these three presentations have shown us very, very precisely on the key issues that we're facing, and that gives us a good indication on where we need to have the take-up into the decision making. And I think that's a good start there.
You mentioned a good point there about communication of science. Marcus, what can be done so that the policymakers, understand the science?
I think Sebastian was giving the answer before. We need to be crystal clear. We need to speak the same language. So we also need to adjust our scientific dialogue to the persons to whom we're talking to. So not too complex, clear figures, repeat, like a prayer wheel. Politicians have agendas, obviously. They have certain obligations. So we also need to be patient as scientists, even if there's an urgency. But we have to make sure that the message is taken and that everything will be done to limit the global warming to 1.5 degrees maximum, but possibly even less.
I mean, have you ever had a situation where you've got the science, but a policymaker or a politician, it just doesn't fit in with their political agenda, so they're not following it?
I don't know whether it didn't fit the political agenda, but I had situations when we first started to work in the Indian Himalayas, for instance. We had meetings with the ministries. We were new to India. We were not Indian scientists. We were coming from Switzerland with the advantage of being representatives from a neutral country. But we first had to build trust, and this sometimes takes years, and it's only with time, after multiple meetings, multiple discussions, the building of confidence, that you can manage to reach the goals. And after years of collaboration with Indian colleagues at institutions in India, research institutions, but also with ministries, I believe that we now manage us with politicians, with policymakers more directly, and they listen to us. So it's not only how we speak to them, but we also need to have this certain level of confidence that they can trust us, we trust them, and then we can reach the goals together, I would say.
Stefan, you're nodding.
No, because many of the things that you said, it rings a bell. I mean, I'm very often asked, what the hell is Switzerland doing in the Arctic? I mean, you are a landlocked country. Isn't this going way too far? And then I say, we are a global player, first and foremost. We are a very globalized nation. What we do is having an effect all around the world. And what happens, there's a very nice saying that I learned during my activity, what happens in the Arctic doesn't stay in the Arctic. So I have hundreds of reasons why Switzerland must engage in Arctic and in polar issues. It's an absolutely fantastic subject, and you can talk about anything. You can talk about human rights involving indigenous people living there. You can talk about economic issues. You can talk about resources. You can talk about geopolitics, climate change, sustainability in the long run. So it's a very, very important subject. And once you are into it, you find so many reasons why the Arctic and the polar regions are relevant, even to a landlocked country like Switzerland.
Eleanor, this discussion between scientists and policymakers and politicians, and do they speak the same language, at a global level, is that an issue? And what solutions do you have to improve what they call the science policy interface?
I love to be between my two fellow panelists actually in this discussion, because the global level is an ensemble of local levels. Global level is not an animal on its own right. So science should be credible and science should be relevant. To make science credible, what WMO does, it collects all the data sets from all official sources all over the world, from every country in the world, and from the affiliated data sets who are making an ensemble. Before we release the figures, the whole world is looking at this. What IPCC did to make it relevant, Intergovernmental Panel actually sits days and nights, days by days, and looks line by line in the summary for policymakers to make sure that every conclusion meets actually hearts and souls of the policymakers. So it's then in 2015 in Paris, we started learning this terribly difficult English word, unequivocal. Now everyone probably can pronounce this word without any mistake. The science is clear. Everything you see in the policy documents requires robust science. So we made this point. Science has a trust. So that is already a huge breakthrough. Now, what my second word is relevant is not sufficient anymore to just give a global projections. Projections should be as detailed as possible, as regionalized as possible, and they should be what if. And the IPCC assessments are exactly doing that, and WMO is trying to do that.